Let's continue with the topic relation and learn what are reflexive, symmetric, transitive and equivalence relations. A relation R in a set A is called reflexive if A, A belongs to R for every A belongs to A. Let us consider an example to understand this. If A is 1, 2, 3, A is a set in which 3 elements are there and R is given by this relation. Then we have to check that for every A belongs to A, A should belongs to R. Means if the element is there, then its duplicate should also be there, belong to R. Like 1 should belongs to R. If 2 is there, 2 should belongs to R. If 3 is there, 3 belongs to R. So this relation is reflexive as A belongs to R for every A belongs to A. So we can say that R is reflexive. So whatever the elements will be there in A, we have to check whether with that element like 1, 1, 2, 2, 3, 3, if 4 would be there, 4, should belongs to R. Then only we can say that R is reflexive. Now the next is symmetric. For symmetric, if A, B belongs to R. Now we have to check if any A, B belongs to R, then the reverse of A, B, that is B, A, should also belongs to R. For all A, B belongs to A. A and B are always will be from set A. Now we need to check if any pair like A, B belongs to R, then its reverse should also belongs to R. So if it is true, then it is symmetric. If not, then it is not symmetric. Now this relation, consider this relation only as example. 1, 2 is there, but 2, 1 is not there. So this is not symmetric. Because if any one example also we will have, like for other example it is there, like 1, 1 is there, 1, 1 is there. Its reverse, all are there. But if one element also exists in it for which we can find counter example, that is for which it is not true, then we will say that the relation is not symmetric. Because if it has to be symmetric, it should be true for all the element belonging to R. But here 1, 2 belongs to R, but 2, 1 doesn't belongs to R. Similarly, one more element is there, 2, 3 belongs to R, but 3, 2 is not belonging to R. So this relation is not symmetric. So we will write it like this: 1, 2 belongs to R, but 2, 1 doesn't belong to R. So it is not symmetric. Now the next is transitive. For transitive, we have if A, B belongs to R and B, C belongs to R. This element should be common here. A, B, C belongs to R. Then A, C should also belongs to R. It means we need to just forget about this B. We need to take this pair A, C should also belongs to R. Like first of all, I will find just common element. Common element to 1 is this. So it means if I will take these two pairs 1, 1, 2. So I will take 1, 1, 1, 2. They both are belonging to R. Then I need to check 1, 2 is also belonging to R. Yes, it is true for this example. But let us check for others as well. Like this is 2 and this is 2. So let us check for this. 2, 2 and 2, 3 belongs to R. So this implies 2, 3 is also belonging to R. 2, 3 is there in R. So let us think about any other counter example. Like I have 1, 2 and 2, 3. Because this 2 is common to this as well. So 1, 2, 2, 3 belongs to R. But 1, 3 doesn't belonging to R. So we need to find out these kind of elements in R for which it is not transitive. If it is true for all, if 1, 3 also would be there in R, then it must be transitive, but it is not. So we will write it R is not transitive, or it is not transitive because we have found the counter example. Now, what do we mean by equivalence relation? If a relation is reflexive, symmetric and transitive. If any relation is reflexive, symmetric and transitive, then we say that relation is an equivalence relation. So if we have to prove that any relation is an equivalence relation, we will show that it is reflexive, it is symmetric and it is transitive. Then we can say that it is an equivalence relation. Let us just see this example which has come this year's board exam in 2025 CBSE board exam. This question was there, question number 37, related to this topic only. A classroom teacher is keen to assess the learning of her students, the concept of relations taught to them. She writes the following 5 relations, each defined on the set A. So here also the set A is given as 1, 2, 3 and 5 relations are given to us. The students are asked to answer the following questions about the above relations. Now here, identify the relation which is reflexive, transitive but not symmetric. So what would be that relation which is reflexive, transitive? So in reflexive we have only these two options, because reflexive means 1, 1, 2, 2, 3, 3 should belongs to R. So only these two options are there in which 1, 1, 2, 2, 3, 3 is there. 1, 1, 2, 2 and 3, 3 is there in R5 as well. So these three options are not valid for first part. So we will just look into these two options only. So these two options are reflexive, transitive but not symmetric. So here I will see which out of these two which is not symmetric. 1, 2 is there but 2, 1 is not there. So what is my option? R4. R4 is reflexive and I need to check whether it is transitive as well. So I will check whether it is transitive. Here I have 1, 1, 1, 2. So 1, 1 will vanish. So 1, 2 is belonging to R because 1, 2 is there. Now for 2, 2 I will check. 2 and 2 will go, 1, 2 belonging to R. So it is transitive as well. So only it is not symmetric because 1, 2 is there but 2, 1 is not there. So this relation is reflexive, transitive but not symmetric. Now here the next is identify the relation which is reflexive and symmetric but not transitive. So what will be that relation? So again for reflexive we have only these two choices and symmetric. Now this R4 just now we have proved is not symmetric, then obviously we are left with option 5 only. So we will check whether it is symmetric but not transitive. Let us check. It is symmetric because 1, 2 belongs to R5, 2, 1 is also belonging to R5. Then 2, 3, 3, 2 both are belonging to R5. So it is symmetric. But why it is not transitive? Let us just find out the example. Here I have, let us just find out for what it is not symmetric. I have 1, 2 and 2, 1. It is belonging like this example 1, 2 and 2, 3. 2 and 2 common, 2, 2 will go 1, 3. Here 1, 3 is not there in R5. You can see that 1, 3 is not there in R5. So we have the correct option is R5. For this the answer was R4 and for this it is R5. Now let us look into the next question. Identify the relations which are symmetric but neither reflexive nor transitive. So these two are reflexive because 1, 1, 2, 2, 3, 3, 1, 1, 2, 2, 3, 3 are there. So these two we will not consider because they are saying that neither reflexive. So these two have gone. Now we have only these three options we need to check from there. Identify the relations which are symmetric but neither reflexive nor transitive. Now out of these three I have to check the relations which out of these three I have to check the relation which are symmetric. R1 is symmetric and R3 is also symmetric because 1, 2, 2, 1 belonging to this is not symmetric. So this option also has gone. So in R1 and R3 these are they are not reflexive, right? And they are symmetric, but I have to check they should be not transitive as well. Now this R3 is transitive because 1, 2, 2, 1 and 1, 1 is belonging to R3, right? But R1 is not transitive. Why? Because 2 comma 3, 3 comma 2 is there, but 2 comma 2 is not there. So my correct option is R1 because it is only symmetric, neither reflexive nor transitive. In R3, it is symmetric, neither reflexive, but it is transitive as well. So I will not take this option. So my only option is R1 here. Now, in the next part, they are saying what pair should be added to the relation R2 to make it an equivalence relation. Now, in R2, to make it an equivalence relation, what all elements we should enter into it? First of all, it should be reflexive. So, we should add 1, 1, 2, 2 and 3, 3. Then, what all elements are there? That we will write here. 1, 2, 1, 3 and 3, 2 are there. Now, these 3 elements are there in R2. This we have added. Now, what else we should add to make it symmetric? Its reverse also should be there, like 2, 1, 3, 1 and 2, 3 also should be there. Now, it is reflexive as well as symmetric. Now, you will see that automatically it will be transitive as well. You can just find all the pairs and you will check that everything is there. Like for 1, if I will check 1 comma 1. Now, 1 is common to this, to this. So, I will check 1 comma 2 is there, 1 comma 3 is there. Yes, 1 comma 2 is there, 1 comma 3 is there. And then with 2 common also you can check all the elements are there. So, these 6 pairs we need to add to make R2 equivalence relation, because for equivalence relation it should be reflexive, symmetric and transitive.